Hi, we are the group Eclipse Grinds My Gears, and I am Edwin Kurniawan. This video, which is done as part of COMP9321 Web Applications and Engineering's Assignment 3, will provide an informative background on our Assignment 2, which was to build an online bookstore for DBLP, which is an online computer science bibliography database. Our web application uses Spring Boot and Spring Security frameworks, and also Hibernate and Postgres as our database. This video will guide you on how to start the project, and then we will explain to you some of the things going on with Spring, and then we will demonstrate the operation of our DBLP bookstore. Let's get right into it. So first things first, here you can see the default workspace for Eclipse. From here, we will create a new Maven web project. Go to File, New, and New Maven project. Click Next. Then we choose the Maven Architect web app. Put in the name of our application and tag Finish. It will take some time until Eclipse has generated all the required files for us. Now, as you can see, Eclipse has finally generated everything that we need, and let's try and open pom.xml. Here you can see pom.xml. Pom.xml is a file containing all the dependencies that Spring Boot uses. And from here, there are a few files that we need to create. For Spring Boot to work properly, within the resource folder, we will need to create a file called application properties. Now, previous versions of Spring use XML files for its configurations, but within Spring Boot, this has been simplified greatly, as we can put all our configurations within a single file, which is what application properties is for. Now, within our main file, we would need to create a new file called Java. And within this file is where we will create our package. Say, let's call it COMP91 Spring Boot, and click Done. Now, within our newly created package, we would need to create a new class, which we would call application. This application class will be the class that will run our web application. And also, alongside it, we need to create a few folders as well. Let's go and create new folders. There's one controller folder, which is for our controller, and then a new folder which is called helper. And then another one called model. Another model called repository. And the last one, which is service for Spring Security. Now, to explain on what we just did, so we just created 4 folders called, 5, called controller, helper, model, repository, and service. Now, helper we can leave blank. Controller would contain obviously the controller for our web application. The model would contain the model for our database. And then the repository is something that connects our model and our service. So in Spring, we are using Hibernate to interface with our Postgres database. And the thing is, Spring uses something called JPA, which is the Java Persistent API. Now, JPA lets us not create Hibernate queries directly. So what it does is that JPA would create HQL for us, and then HQL would generate SQL queries for us. So there's actually 3 layers for our database access. Now, after you've completed creating all the necessary folders, we can start and create our application. As we already have a working application right now, we will leave this new application and we'll start explaining how our application works. Now we'll begin from application.java, which is the heart of our web application. Now, as you can see here, application extends Spring Boot Servlet Initializer. This is for when the application is being exported. So in actuality, application.java only requires our main function. But then if we are going to export this project into WAR file, this function would be needed. Now, this function is what it does is basically when it exports into WAR file and the WAR file is being executed, it knows which function to execute basically. And by doing this, it knows that it needs to execute application.class. Now, Spring works a lot by using what are called annotations. Now, one such annotations is something like this. Now, the Spring Boot application annotation is to indicate to Spring that this is the main application that it is supposed to run when it's starting up. The override annotation means that there's already an existing function and that we are overriding whatever is inside that function into what we write here. After application.java, now we will go and take a look into one of our controllers. Say, for example, we would like to look at an item controller. Now, again, a class is designated as a controller through an annotation for string. And also a new thing for string, a new annotation, which is called AutoWire. Now, essentially what AutoWire does is that whenever we create an object, say for example, we create an object of item repository, we create an object of type item repository with the name of item rep, it does not create a new object. Instead, we look at an already created object called item rep. So basically what AutoWire does is that it's similar to how a pointer would work in C. So if we do AutoWire item repository item rep, what we will receive back is a pointer to the item rep. So whatever we do to the item rep will not change whatever's already available. And next, we'll look at the request mapping. This is so basically it shows that it tells Spring that when a request is sent from a page to the controller, this function is to be accessed, and the values here correspond to whatever values is being sent from the form in the page into the controller. As you can see that, so everything that we want to, so this model.model is what we pass back to the page. So objects are passed back into a page through something called a model, and by attaching an attribute into the model, we can then access the attribute inside the page. No, so whatever function in every function in a controller will only return a page to render. That's why the return will always be a string, and it will lead to a page to render. So aside from just the usual model, we also have, for example, here in the show result function, aside from just model, we also have item. Now, model is something that we pass from the controller to the page, but the item here is something that we receive from the page. So basically, it receives an empty item object from the page, and then we fill in the item with all these methods, and then we chuck it in inside the model, and the model is what we return back into the page. And also, Spring Controller also supports both get and post methods, but it needs to be specifically stated like this, right? Either request method.post, request method.get, or both of them in the same time. Now, moving on from the controller, we will take a look on our item object. For example, on our item object, and we can see that the item object contains a lot of annotations, and these annotations mean they are used differently than each other. For example, this entity annotation is to tell our database that the item is an entity, and that the name inside this brackets means that in the table the name will be item. So for example, if we change the name within these brackets, say for example to objects, then within the database the table name for this would be object rather than item. And so we can see that the ID annotation is to tell the database that the ID field is the ID field in the table as well. And then there are two annotations here, not empty and column nullable false. Now, these annotations work a bit differently in the sense that the not empty annotation is for the string, for the title object, while the column notation is for the title field within the table. So the annotation within an entity could refer to its properties as an object or its properties within the table. So in this case, we can't have the title of an item be missing, and that's why we set the notation to be not empty. And also within the table, within our database, we don't want the title to be false, and that's why we don't want it to be null, and that's why we need to set nullable to be false. This is basically to just play it safe. And then there's also pattern. Now pattern works in the database layer, and what it essentially does is that it limits the entries to just this, and that the case is insensitive. And also, and then we have now this is an interesting one. There is an annotation called many to one, which is related to our user ID. So what this annotation does is that it allows, basically it lets one user ID to have many items. And if we look at our user entity, we can see that it's not in the user, it's in the user detail, and we can see that the user has a one-to-many annotation. So the way this works is that one user may have multiple items, while one item will only be tied to a user. So we need to explicitly create this two-way description, so that whatever we do to the item, there will be an effect in the user side, and whatever we do to the user, it will also give an effect to the item. For example, if a user creates an item and we delete the item, the user should know that the item has been deleted. Vice versa, if a user creates an item and the user gets deleted, we also want the item to know that the user has been deleted and that the item should no longer exist. This works when the one-to-many and many-to-one annotation is given. Now, after taking a look at the item object, we are going to look at the item repository. Now, as you can see here, so we need to create an interface called the name can be anything, but since this repository will be for the items, we will name it item repository and extends CRUD repository. Now, by extending CRUD repository, it will automatically provide us with 4 functions, which are to create, to delete, to update, and to read from the database. This is one of the magics, you can say, of Java Persistence API. And by putting item and long means that it is for the item entity and that the ID type is long. So the way CRUD repository works is that it has what would be called some keywords, such as, for example, we know that within the item object there is a status, and one of the keywords of Java Persistence API is find by. So if we create a list by the name of find by status, it would automatically pull from the database by status, and also find all by order by ID ASC is, so the keywords there are find all by order and ASC, and ID is the only one that is not a keyword. So basically what it does is that when it pulls the ID from the database, it would pull it by order and in ascending order. For more detailed information regarding JPA's keywords, you can look it up at their documentation. JPA also supports us to do custom queries by ourselves, and that is shown by doing the query annotation with the database query that we want to do. And also, if we want to modify anything within our database, we can't just do query and that's it. We need 2 more other annotations, which is modifying and transactional. It's just the way how JPA works. After looking at all the key components of our web application, we will now show you a demonstration on our application. Now I'd like to give you a glimpse of what our website is like. So when you enter the home page, this is what appears. As you can see, you can search. There's a normal search bar up here. There is an advanced search hidden within this button, and then down below you can see there are random picks from which you can choose from, and there are also the login and register button. Now let's try searching for a book. So this website is only usable by users. So that's why whenever you're not logged in, you won't be able to do anything. That's why when you first search, you first need to log in first. Just for the sake of demonstration, I'm going to be logging in using the admin account. And so now we are inside the website with an admin account. As you can see now, we have a lot more tabs up here, a lot more buttons. There's the logout buttons. There is the my cart button to check inside my cart. There is my items. The my items bit is the books, is the publications that we are selling. The edit profile is to edit our details. The graph search is to show the relational graphs of whatever we're looking for, and the admin panel is a special page that can only be accessed by the admin. So first of all, I would like to show you, let's search for book. As you can see, there are a few books. For example, I want to know more about book 2. We can click and we can see more details for it. Let's add it to cart. As you can see, the book 2 has been added to cart. We can remove anything from our cart by simply checking the checkbox and click remove. I can just go back to search, and let's add an item. For example, the admin wants to start selling a new item. We can press sell an item, say it's called COMP9321. The type is, so the adding a new item requires a type and status and price. Without it, the website will protest, and so we need to put in some values inside. Let's say myself, say this is to sell. Now the difference between sell and pause is that when you're selling, user can search for it, while when you're pausing it, it won't appear in search results. I want to sell my journal, and so I press sell, and price, let's just put in some random price of say $30 and submit. And you can see in book 2 there is the journal that I just added, which is called COMP9321. If we search for comp, it will appear in the result. Now about the admin panel. So the admin panel has the capabilities to view the activities of customers, to ban items or ban the users. So for example, currently registered in the site are 3 users, user 0, user 1, and user 2. For example, we can ban user 1. It will take some time, and we'll reload the page. Now we can see in the banned user that user 1 has been banned. This way, user 1 won't be able to log in to the page. And also, every item that is sold by user 1 will be removed from the page. Now, we can unban user 1. And after unbanning user 1 will be able to proceed on his activities once again. Now, onto graph search. So, graph search requires an exact match with whatever field we're looking for. And if it's not a match, the graph search won't return anything. It will only return us to an error page. For example, let's try for publication that does not exist. Say for example, I would like to put in the name of an author, say Juice and Griffith. By searching his name in a graph search, it will return us to an error page. Going back home and looking at the author search, we can see that it does return the data, and we can see his graph, which can be freely manipulated by the user at will. Now, another feature that I haven't shown you yet is the checkout feature. So basically, any user could add books to his or her cart, and then the user could check out, which would then send email to the user, and also removing the checked out items from sale, which means that if a user were to try and look and search for that item, the item won't appear in search. So to demonstrate that, we will add a few items. So first, journal 11, we'll add it to cart, and then we will look for other journals, and let's try adding, say, journal 5. Add journal 5 to cart, and then I want to check out journal 11 while keeping journal 5 in my cart. I can easily do that by checking the box and check out. It will take some time, and after it's checked out, we can see that journal 1 does not exist any longer. Although, because I'm currently using an admin could view that journal 1 has been sold, and that's why the item was removed, while journal 5 stays in my cart. That is all for our DBLP website. Thank you so much for listening. Goodbye.